In our earlier video, we learned that rational numbers. We learned rational numbers are closed under the operations like addition, subtraction, multiplication, and division. That is, when you add or subtract or multiply any two rational numbers, the result which you get will also be a rational number. Now, in this video, we are going to explore the same operations on irrational numbers. On these, what would be the sum or the quotient or the product or the difference of any two irrational numbers, would they also be irrational? This is what we are going to explore in this video. So let us first take any two irrational numbers. Say we know that square roots of imperfect squares are irrational numbers. So let us add root 2 plus root 3, both of them being square roots of imperfect squares. Now can we add them? Yeah, we can, because we of course know the decimal values of root 2 and root 3, but we know that they are non-terminating. The decimal values of root 2 and root 3 are non-terminating and non-repeating, also called as non-recurring. As they are not, both of them, both root 2 and root 3 are non-terminating and non-recurring, we know that the result also would be the sum. The sum of root 2 and root 3 would also be a non-terminating, non-recurring decimal. So, this is going to be a irrational number. The sum of root 2 and root 3 is going to be an irrational number. But it is not necessary always that the sum of two irrational numbers are irrational. We can always provide a counter example for this particular result. What if I add root 2 plus the negative of root 2? So I am going to get a rational number, 0, isn't it? So we have a counter example for this. So we can now say that the sum of two rational numbers need not always be irrational. The sum of two irrational numbers need not always be irrational. And by saying the sum, even the difference has been proved. What is root 2 plus negative of root 2? If you multiply the signs, it's root 2 minus root 2, 0. So once you prove a result for the sum of two irrational numbers, the difference also holds good. Similarly, let us try multiplying also. What if we multiply two irrational numbers, root 3 into root 3? You get 3. Square root of 3 multiplied by square root of 3 is 3, right? So which is a rational number. So the product of irrational numbers need not always be irrational. And what if we decide to multiply root 3 multiplied by 1 by root 3? The root 3 in the denominator and in the numerator get cancelled and your answer is 1. So it becomes a it becomes a rational number, right? 1 is a rational number. So since we have proved for this product, it is the same as proving for division. Division of two irrational numbers, the answer, the quotient, need not be irrational. So once you prove a result for the product of two numbers, it holds good for division also, for the quotient also. So with all this in mind, let us proceed to add two numbers which are, one of them is a rational number 3, the other is an irrational number, square root of 3. Now we know that while adding these two numbers, we are going to get an irrational number. It's going to be a non-terminating, non-recurring decimal, because square root of 3 is non-terminating, non-recurring. What if I multiply this with another irrational number, 3 minus root 3? Both of them are irrational. So let us just find the product of these two irrational numbers. Both of them are being irrational. We are going to find the product. For those of you who recognize that this is of the form 3 plus root 3 multiplied by 3 minus root 3 is of the form a plus b into a minus b, straight away, if you remember the formula, it is a squared minus b squared. But I don't insist that you should remember the formula, even I don't. We can just proceed multiplying, just one step more. Just one step more, you can say 3 multiplied by 3 minus root 3 plus root 3 multiplied by 3 minus root 3. We are just multiplying the first term with 3 minus root 3, 3 into 3 minus root 3 plus the second, let me change the color, root 3 into 3 minus root 3. So just this one step is extra. It's not necessary that you should remember formulae, and that is the intention of our channel also. We want you to understand everything to the basic, to the core, without memorizing anything. So 3 into 3, 9 minus 3 root 3 plus root 3 into root 3 is plus 3 root 3 plus into minus root 3 into root 3 is 3. Right? So if you observe, we have a negative of 3 root 3 and we have a positive 3 root 3. So just cancel them because they add up to 0. Both of them add up to 0, and the result is 9 minus 3, 6, which is a rational number. So here in this particular example, we have proved that the product of two irrationals has given us a rational number. But once again I insist that is not always the case. Just try multiplying 3 plus root 3 twice, 3 plus root 3 into 3 plus root 3, and you will know why I said this. They are not always rational. The product of two irrationals are not always rational, because here you will have an irrational counterpart also. So the conclusion from this video is, irrational numbers may not be or are not closed with respect to the operations addition, subtraction, multiplication and division. So as opposed to rationals, irrational numbers are not closed with respect to addition, subtraction, multiplication and division. But if you observe, all the results of sum, all the sum, the product, the quotient and the difference of irrational numbers are always real numbers. Isn't it? They are not irrationals, but they are real numbers. So we can conclude that real numbers are closed under these operations. They are closed with respect to. Addition, subtraction, multiplication and division. I hope you understood. Thank you.